Hello everyone and welcome to my Lab 3 of Physics 1. This lab has two parts, and the purpose of part 1 is to simulate the trajectory of a star orbiting a black hole in GlowScript and determine the mass of the black hole. And in part 2 is to determine the ship's velocity and forces working upon the ship and the neighboring moon to determine the ship's orbit. So you set up a three-body gravitational system simulation with a planet, moon, and spaceship, where the planet sits at the origin and the moon in orbit around it, and the moon and ship orbit around it. Calculate the gravitational forces in both the moon and spaceship at each time step, counting for all pairwise interactions, planet-moon, planet-ship, and moon-ship, and also the gravitational forces they exert on each other. And it tells you whether the ship and moon crash or remain in orbit when they're orbiting the planet and what that trajectory looks like. The main concepts used are Newton's second law to calculate net force from momentum changes, the law of universal gravitation to calculate gravitational forces between the bodies, the momentum principle, and the parallel and perpendicular components relative to motion and what those contribute to. And for part 1, the system is the orbiting star and the surroundings are the black hole. And for part 2, the system is the spaceship and moon and the surroundings are the planet. Here are the equations used. As you can see, Newton's momentum principle that I previously mentioned, as well as the calculating gravitational force. I also have the calculations for F net parallel and F net perpendicular, which when added together, make F net. Here's my coding for part 1, and the goal was to find the black hole mass, and the net force equals centripetal force in this particular situation. And the black hole's origin is at 0, 0, 0, and the black hole's mass is found to be 8.86183 times 10 to the 33rd, which was found after several iterations after the planet circulated the black hole. Here's my part 1 explanation. We've already concluded the black hole's mass. Gravitational force causes the star to have an elliptical orbit around the black hole. This makes up the perpendicular component of the force. The force is not constant and it gets smaller the farther away the star is from the black hole. By Newton's second law, the net force is the rate of change of momentum, and likewise, F net parallel and F net perpendicular are directly equal to the parallel and perpendicular components of dp dt. The parallel component of the force changes the speed of the star, and then here I just have the colors of the different vectors that you can see on our orbiting mass. And the potential errors in this, as I might have had errors when calculating the mass values, which arise from the limitations of using GlowScript. And here's my coding for the part 2. As you can see, the ship was eventually able to break orbit, and although it's not a figure 8, it's not a consistent orbit, and it was able to go around more than once. My part 2 explanation. The speed of the spaceship is originally positive in the x and y direction, but changes directions due to F net perpendicular. So why is the orbit not regular? The orbit is irregular because there are 3 objects in the system. That should say 2 objects in the system, where the gravitational pull of the planet, moon, and spaceship all interact with each other simultaneously. These mutual gravitational forces compound over time, resulting in a non-constant trajectory. And there are possible errors, including coding mistakes / computational errors when inputting values that could have resulted in the trajectory not being that perfect figure 8. So what does all of this mean? The net force and its parallel and perpendicular components equal the rate of change of momentum and the parallel and perpendicular force components. Parallel force equals speed and perpendicular force is changing direction. If we combine the system, it has a black hole, moon, star, and planet. There will be 4 objects within the system, making the necessary speed for the crash prevention simulator pretty hard to calculate, and also making the orbit pretty chaotic. I highly doubt it would be a circular orbit. It would be very difficult to make sure that the objects did not crash. And the black hole would be the dominant interaction, as it inflicts the largest gravitational force. The object with the smallest mass would be affected the most by the black hole, so probably a spaceship. Okay, that's all. Thank you for listening.